This video will explain how to create the sketch for the function in question number 3 in the Minds On. First of all, we need to be familiar with the 5 key points for cosine. They are listed here on the right. We have a graph of cos here. We have maximums at 0 degrees and 360 degrees. We have a minimum at 180 degrees. And we have two zeros at 90 and 270. Now we will apply each transformation to those 5 key points. First of all, the amplitude. We have an amplitude of 2 and there is a reflection about the x-axis. To account for the amplitude of 2, the value of each maximum will be doubled and the minimum will be doubled. So instead of 0, 1, we will have a maximum at 0, 2 and at 360 degrees 2. The minimum, which occurred at 180 degrees and had a value of -1, will now be -2. We have now accounted for the amplitude of 2. This is a graph of 2 cos x if I connected the dots. The zeros are unaffected by the amplitude of 2. Now to account for the reflection, I need to flip these points over across the x-axis. So the 2 maximums will flip down here and become minimums, and the minimum will flip up and become the maximum. I'll do this in a different color. There's our 2 maximums. They flipped across the x-axis. The x-axis is behaving like a mirror. And the minimum flips over and becomes the max. I'll erase the old points. We have now accounted for the amplitude of 2 and the reflection in the x-axis. Now we will account for the period change. The period is now 180 degrees. That means that the cycle that we see occurring from 0 to 360 must occur in a much shorter cycle from 0 to 180 degrees. The end of our cycle, which occurs at 360 -2, must now occur at 180 degrees -2. So I'm going to draw a new endpoint for our cycle in a different color. The beginning of our cycle has not changed. Every other point must now be adjusted so that it occurs in this much shorter period. Our minimum, which occurred halfway between the beginning and end of our cycle, must also occur halfway between the beginning and end of our cycle now that is occurring between 0 and 180. So halfway between 0 and 180 is 90 degrees. So this is the location of our new maximum value. Again, it used to be at 180, which was halfway between 0 and 360, but it is now at 90, which is halfway between 0 and 180. Our zeros, which occurred halfway between a max and a min in each part of the cycle, will also be in the same location. So halfway between a minimum and a maximum, we must have a 0. The minimum occurs at 0 degrees, the maximum at 90. Halfway between that is 45 degrees. Same thing on this side of the cycle. 90 degrees, 180, we need to have our 0 occurring halfway between, which is at 135 degrees. If I connected these points, I now have a graph of -2 cos 2x. The period of this graph is 180 degrees. I'm going to erase the other points. Now it's time to account for the translations that are occurring in my graph. I have a phase shift of 30 degrees to the right and 2 units down. So each of these points must be shifted to the right 30 degrees. Note the scale is 30 on my grid, and 2 units down. So each point I will shift to the right and down 2. So starting with my beginning point for the cycle, over, I'll pick a different color, over 30 degrees, down 2. There's our new beginning point. I'll do my end point. Right 30 degrees, down 2. There's my new end point. My maximum, over 30, down 2, will end up on my x-axis. The zeros, over 30, down 2, is right there. This 0, over 30, down 2, is right here. I'm going to erase the red points so I can have my final transformation. There we have it. I'm going to connect these 5 dots, and that will represent one cycle of the function. Now to create the remainder of the graph from negative 360 to positive 360, I want to repeat this pattern of points. So again, the end of this graph must occur 180 degrees later. So right now I'm at 150. I want to go 180 degrees later and continue this pattern. So every point is going to be repeated 180 degrees later. So let's take, for example, this maximum. We want to repeat it 180 degrees later, which would be right here. This point would be halfway between. This point would be approximately here, and this point, that end point, would just be out of sight. I'll continue connecting points. Let's go to the left. 180 degrees to get the end of the cycle would be right here. My maximum halfway in between the beginning and end. My zeros halfway between the maximum and the minimums. Right here and right here. Connecting these, I've created another cycle. Let's do one last one. There's the end of this. The maximum halfway between the beginning and end. Our zeros halfway between the maximum and the minimum. And there's our next cycle. And I can just finish this off because I know that this will come up. But this will just be out of sight. And there we have a sketch of the function by transforming the 5 key points, applying each transformation one at a time, and then repeating the cycles to create the graph from negative 360 to positive 360 degrees.